All right, ladies and gentlemen, hello and welcome back once again to the longest running show in the world about data. It's called DM Radio. Yours truly, Eric Kavanaugh here. And folks, we're going to talk about a really interesting and dense topic today. We'll be talking to Terrence Sheflin and Sami Akbay of a company called Insight Software about hallucinations and how do you get around hallucinations? How do you avoid hallucinations from generative AI? Gen AI is extremely powerful. I mean, ChatGPT has taken the world by storm. It is tremendously disruptive in all kinds of different ways, but it is very powerful. It's very compelling, but it does make stuff up. And we're in the world of business intelligence and data and deterministic outcomes and wanting to get the right answer from our data to make business decisions. So hallucinations are no bueno, at least writ large. It's not good at all, and they cause trust issues. And folks, I've been in this business a long time, and I know, and I can tell you that when you lose the trust of your enterprise users, it's gone. They're not going to use the system that you built if you get wacky answers. And I just saw today there was an article, or actually yesterday I saw an article about a chat bot that was wrong out of the box. It just went wacky, like right out of the gate, and the company was all worried about it. This is a story in the media. I'm thinking, that is not a good sign. If you deploy your chat bot and like right out of the gate, it's all wacky. Probably didn't connect to the data properly. There could be any number of things that came into play here, but we're going to find out from our guests today. And like I said, Insight Software is the company. They actually are an amalgam of lots of different companies that I've worked with over the years. Companies like Zoom Data, companies like Logi Analytics. Now you got Logi Symphony and Simba Technologies. So I've been in business for a long time, and I happen to know that Simba is the company that wrote the ODBC and JDBC drivers. And folks, these drivers are ubiquitous. They are the workhorses of data access around the world and have been for decades. I mean, for 30 odd years. And they really are the foundation. And I'm really fascinated by this concept of them serving as a guardrail, as almost like a first line of defense. So remember, with ChatGPT, it's a very important thing to understand how these technologies actually work. And the way I describe it, folks, is that you can't crunch letters and you can't crunch images, but you can crunch numbers. And that's why these large language models will vectorize or tokenize text or imagery and then process it and then decode it basically back into text. Well, that is what's called a lossy process. You see this in the world of recording devices, where if you make a tape of a tape of a tape of a tape, it's a lossy process, meaning you're losing little bits of fidelity along the way. And that's part of the reason why you get hallucinations. It's not really hallucinating and it's not really a lie, but it's what's called a confabulation, basically. You have to watch out for it because they are very compelling in the way they give you these answers. It sure looks correct, but it doesn't necessarily have to be correct. You have to kind of double check things. So how much double checking do you want to do? The answer is a bit, not a whole heck of a lot. So with that sort of broad introduction, let me bring in quickly Sami Akbay just for some comments, and then we're going to go deep with Terrence Sheflin. But Sami, I came up with this analogy, which I think is kind of funny, that for the last 75 years, we've been pushing this boulder up this hill. And the boulder represents all the engineering work for designing databases and applications and networking protocols, the internet to be able to talk to each other and all these things. And but one thing was never in question, which is that you would get out of a system what you put into a system. That's what a database does. That's its job. So we've made it faster, more performant, more concurrent users, all kind of stuff. But never, ever, ever was it in question that you would get out of it what you put into it. And now that is in question. So by analogy, it's like we got to the top of the hill and now the boulder is rolling down. We're like, whoa, we're trying to kind of stop it and mitigate it. What do you think about that? Like, is it just me or is that kind of crazy?
No, I love the analogy, and hi Eric, hi everyone. Always a pleasure to be here in this forum. So we're not trying to stop the boulder on the other side. We're just trying to control it, and
Right.
that's when you got the big boulder to the top and you start letting it roll. That's a lot of power, and power without control is not a great thing. And I think at this point, what we're trying to do is we're trying to put some guardrails around it. We're trying to put some controls around it because when you can, great things are bound to happen. I'm
Mhm.
excited about the fact that the boulder is at the top and it's starting to roll on the other hand, on the other end. And I think another perspective might be, oh, it's all just downhill from here. It
Right.
probably isn't downhill. It's probably going to be exciting times ahead.
Yeah, I think so too. And maybe Terrence, I'll bring you back in. And there are lots of issues to discuss here, and a lot of things that most business users may not fully appreciate or understand. Because again, it's so compelling. It's so interesting to sit there and give these prompts and get back complete answers with all sorts of references. But there are lots of things the LLMs do not do very well. One of them is read database tables, right? I mean, that's kind of an important thing in BI is reading tables. But what are your thoughts about that, Terrence? And what are you folks doing about it to help your clients not deal with these unfortunate issues?
Yeah, so I think the first question that kind of came up was from our executives. They've got data in all sorts of databases, and they came to us and they're like, I just want the LLM, our AI service to be able to talk to that data. And so I want to envision, like for you, Eric, like think about it. You've got AI and you've got billions of records in a database. And I ask you, create me an AI to talk to the data. How are you going to do it? Are you going to vectorize, like you said, billions of records? Well, that's not going to work. Are you going to take all billion records and give it to the AI? That's not even feasible, right? And so this is a really big problem that everybody is trying to solve. And so we've found that we've been able to build on top of our existing technology that does a good job of getting the right data to the LLM so that it can make good responses. Because the problem is kind of like on the data side. It's not the LLM. We have to get the right data ahead of time to the LLM for it to get a valuable answer back.
Hmm. And that's the prompt engineering side, right? So you want to give the LLM the correct values, the correct information, but also the correct guardrails, essentially. Is that a good way to put it?
Yeah, that's pretty much it. And I think like if you want to go down at the very lowest level, when you think about when you ask ChatGPT a question, like what is happening, at the very lowest level, it's always the same thing. A block of text is given to the LLM with no other context and no background, just a big block of text, and it gives you back text. That's all that ever happens. Your past history and data, there's no special mechanism to give it all this context. It all just ends up as this huge string that it has to look at. And so, yeah, it's all about formatting that string in a way you hope it will understand and in a way that it can make a valuable answer out of.
Yeah, and there is an issue with both not enough data and too much data. Like this is the other interesting thing I've heard is that if you try to give it too many rules, too many guardrails, it just kind of skitzes out and doesn't know how to deal with that. So how do you know the optimal amount of construct to feed into this thing to get the answer that you want?
Yeah, that's a really tough problem. And like one thing the listeners may not be aware of is that the system message that Anthropic and OpenAI have that have all these guardrails about healthy responses and this kind of thing are huge. So even when you add your part in, there's a huge hidden thing that you're not even seeing
Mm,
that's already there. And so there is like kind of a sweet spot, but it's different for every LLM. Like Gemini has a 1 million token context window. But if you actually filled it up, it wouldn't give a valuable response because there's just too much, like you said. And if you don't give it enough data, of course, yeah. So really, it's less prompt engineering and more artistry at this point, I would say.
that's interesting. And there are lots of other issues, and there are some really interesting architectures that people have come up with. There's MCP, Model Context Protocol. I've never seen anything take off faster than MCP. I think there are like 80 different MCP servers out there. That's one thing to keep in mind. There are knowledge graphs that can be used, but there is a real challenge and a real concern about just giving an LLM direct access, even through an MCP, to your enterprise information systems, right? So that's why you want to have an appropriate level of guardrails such that you're not just giving this LLM visibility into all your enterprise data, which could give you privacy concerns. It could give you all kind of concerns, right?
Yeah, that's absolutely right. Like what we saw over the past few months with the rise of MCP was people creating basically pipelines directly into their database, and they would hand it off to the end users, and they say, "Hey, end users, ask some questions, and it's going to generate SQL for you." Well, you can kind of imagine where this went, right? The SQL was all over the place, and it was getting things it shouldn't have got, and it's not scalable at all. And so now it's kind of come back, and they're like, "Well, how do we solve this? You need like a semantic layer, you need governance, you need auditing, you need security, row level security." And yeah, we've kind of gone back to all the original things that BI existed to solve and is now applying to AI as well.
Hmm. Yeah, well, it is a bit of a black box, and so it's like we need to be able to shine light on what goes in and then scrutinize what comes out, right? Because if you can't govern what's inside the LLM. I mean, we joke that OpenAI is a bit of a misnomer these days because it's now closed AI. It's not open at all. So you have to control what you can control, and then from an audit perspective, be able to explain that to for an auditor who shows up knocking on your door, right, Terrence?
Yeah, and like you can definitely explain the inputs because you have control over that, but it's much harder explaining the outputs because it is non-deterministic and you don't really have control over what it's going to do. Part of that control is coming back. For example, in private clouds, you can now deploy your own version of Sonnet or GPT, right? So that's kind of coming back under the control of enterprise corporations, which is a good thing. So you know your data is not being farmed out. But yeah, part of it you just can't answer for.
Right. Well, and there have been some pretty bad hallucinations. I mean, the one that got a lot of attention was, I think, a car dealership where they put the bot
Yeah.
on their website, and someone asked, which car should I buy as best?" And it mentioned some other car they don't even sell. It's like, whoa, hold on a second. I mean, how do you, from a programmatic perspective, how do you stop that? Is it just another layer after it comes back from the LLM where you say, okay, check this and make sure that it's one of our cars? I mean, because you're hearing a lot about this concept of hybrid search, but from a programmatic perspective, how do you address that?
Yeah, so like I think the first part, of course, is what you mentioned with the prompt engineering. So there's a lot of best practices over how you format your prompts and how big they are. So like Markdown, for example, is a way to format text, and that the LLMs respond really well to it. So there's those best practices. There's the data you give it, and how do you give it to it? Is it in JSON? There's a new format called Tune that looks very similar to CSV. Maybe that's how you do it.
Hmm.
There's a lot of trial and error and then holding the response to some standard. There's different ways of doing that as well. One example is you could have multiple LLMs and they can all cross-check each other. The
Hmm.
response takes longer, but you're more guaranteed a thorough answer. You could also do what you said and use traditional code and like, okay, did it actually, did it give the email address for a competitor or something instead, right? Like catch that ahead of time.
Hmm. Yeah, I think what you're laying out is the QA part of the process, right? The quality assurance. And so, like you say, some companies can just use a separate LLM. I've seen there's a company, Vectara, is talking about that, where you use the one engine to give you the answer. And then once that answer comes out, a separate engine comes in and looks at the input, looks at the output, and says thumbs up or thumbs down. That's a guardrail, right?
That's right. Yeah. And as a developer, like I still write quite a bit of code. I like to get code reviews from GPT-5 and then paste them into Sonnet 4 and make them argue with each other, right? Because they have like different perspectives. Yeah, and it's really fun to see what they call out. They're like, no, this guy's dumb, right? He called out something silly. So yeah, it's getting the different models to sort of fight a little bit with each other does produce much better results.
Yeah, that's very interesting.
Terrence,
Sammy, go ahead.
you know, uh, it's kind of interesting. You mentioned that you're getting the two different models argue with each other. If you drop names, if you tell, for example, Codex that Claude said such and vice versa, they start to get a little catty as well. And
Isn't
that
that
takes us
wild?
to, I think, this whole hallucination. Terrence was saying that, like, okay, so hallucinations are kind of by design in large language models. Do you want to kind of, tell us a little about that, Terrence? Because I think that's actually an insightful uh, thing because you want these models to have the creativity, um, but at the same time, you want them to use that creativity in the right context, right? What do you think about that?
Yeah, that's right. So we call when we talk about hallucinations, it's more about you gave it data and it like just didn't read it, right? But at a larger, like at a higher level, when you ask ChatGPT to write you a story, it's essentially hallucinating a story for you. And if it didn't do that, then when you ask for a story, it would just give you the same story every single time. And
Right.
so the creativity part we all want, right? It's the non-deterministic behavior of the weights on the underlying model. But what you do want is when you give it numbers like sales data and you say what would, what month had the worst or best sales, you want the same number or month back every single time. And so there's like a balance in there, but these are contradictory requirements on the LLM. And so it's trying to figure out how to get the best of both worlds. That's the hard part.
Hmm. Well, and that's what you want is you want the best of both worlds. So all these guardrails and policies and protocols are designed to tame the beast, if you will, and to kind of shepherd the output that you get from it, because the creativity is very compelling. And just being able to speak in natural language to a computer system and have it speak in natural language back, that is a huge development in the world of enterprise systems. We haven't had, I mean, we've had NLP for years. That's not new, but this is like supercharged NLP. Well, folks, we're up at our first segment break. We'll be right back. You're listening to DM Radio. All right, folks, back here on DM Radio talking to Terrence Sheflin and Sami Akbay of Insight Software. They are the company that has a whole bunch of technologies. Simba, those are the folks who wrote the ODBC and JDBC drivers. They have Logi from Logi Analytics. They have Zoom data. They have Dundas. They have all these different technologies that have come together. And that's kind of what you need for the big picture. So we're talking about LLMs versus business intelligence. And business intelligence is deterministic. I want to know exactly what the numbers are, but the LLMs give us context around that and they can explain things. And you were talking about that, Terrence. You made a really good point. And one thing I love about these LLMs is you can use them for all kinds of different things. We did a webinar earlier talking about the summarization component, and my buddy Mark Madsen, who is a bit of a skeptic about these things, he's like, it doesn't actually summarize. And that's true. It doesn't technically summarize. It sort of recodes. It takes a look at that, and then again, it converts it to mathematical vectors and kind of balances things out, and then comes back and gives you the answer. So you always have to keep that in mind. But there is a very compelling side to that story, which is it gets people engaged. So in this segment, we wanted to kind of dive into a little bit going beyond the pilot phase. And there's all this hullabaloo out there about, oh, and 90% of the projects fail, MIT. I mean, I think that was a bit of an exaggeration. And there's something to be said for how you ask the questions and what you're really fishing for. But there is real value in these things. But in terms of getting beyond the pilot, maybe Terrence, I'll throw it over to you. What are some tips that you have for folks to help them get on the right track and set their expectations appropriately such that it's not viewed as a failure?
Yeah, that's a tough one. I think it has to be approached like any software project, even if it's not all software, where, the first 90% is half your time and the second 10% is like a huge
R-
amount of time, right? Like it's
Right.
and so I think that's where you need to set the expectation because doing the first initial pilot, it always goes by fast and there's lots of tools to help prototyping. But then as soon as you get over to CISO, you talk about security and governance, that's where you start to get into the weeds and everything kind of slows down. And so even if you think about it upfront, think about security, how you're going to partition it per user. If that's in your mind at the very beginning, then that will definitely be a big asset when you're in the second half.
Yeah, I
Hmm.
want to add something to that. So typically when you do a POC, the way it goes is that you go to the business folks and you say, "Hey, I'm thinking of doing something. Do you think it would be useful?" And they tell you, "Yeah, let's give it a try." Then you go to your IT guys and you get some resources provision to access your, I don't know, servers, GK, whatever, Kubernetes is like some virtual environment, and you get some tokens. And then, of course, to make this meaningful, you need to get some enterprise data because without your own enterprise data, there's nothing very special about it. You go to your data people, they give you a data set, usually curated, clean, something that you can work with. Often it's synthetic. Then you build
Hmm.
something, you take it to the sponsors of the project, the business guys, and they look at it and they say, "Wow, this is amazing. Let's put it into production." And that's when all of the troublesome parts start, right? Because first of all, everything that Terrence said, like, the CISO has to sign off. You need to make sure that this is secure. You need to make sure that you're not exposing things to the wrong audience. The data is properly governed and controlled. But the second part of it is, do I even have access to that data in a timely fashion? I mean, in a POC, if I'm using 2-year-old data, um, it's a POC, right? I'm just trying to make a point. But the moment that I go into production, I'm going to put something in the hands of operational users. You need to have that data fresh in a timely fashion. It needs to have proper governance. It needs to ensure that only people who are entitled to see that data gets to see that data. You also need to make sure that you're not putting undue burden on your OLTP systems, right? I mean, hey, look, a human can ask so many questions in a short amount of time, which will
Right.
inevitably increase the load on your, databases and data sources. But a machine asking questions, it could just go really wrong because it can ask thousands of questions per second, and suddenly you could bring your operational systems to a halt. So the good practices in data management apply at a magnitude. So that's one of the biggest reasons why it's not easy. It's very easy to build things. It's not easy to put them into production.
Hmm. Oh, and you have to constantly check and validate. I think that's one of the layers. And I keep talking about how these systems, because they are so much different than traditional enterprise systems, you do have to treat them differently and manage them differently. And that is going to involve layers. So you have a deterministic layer, and then you bring in the LLM to add some context, and you have another layer after that, like we say, to quality check. So it's more involved. But again, the reason we're doing this is because there is such a compelling value that can be gotten from these generative capabilities, right, Terrence?
Yeah, that's right. And I think we have to leverage LLMs for what they're useful. And they're very good at English language and translation. There are some things that they fail dramatically at, right? I think one of the famous examples was how many R's are there in strawberry?
Right.
They all got it wrong. Uh, and they can't really do math either, right? Like you give them, 5 plus 6, and they can't do it. And so you need to use them for what they're good at, target them, and focus them, which I guess is kind of like your boulder example too, right? You're guiding it and using it where it's useful.
Yeah, and you bring up a really, really good point, which is using it in the appropriate way. I remember when ChatGPT first came out, and there was some New York Times reporter that wrote, "Oh, it told me to leave my wife and marry me and all this kind of stuff." And I'm thinking that was a misuse of the tool. You're trying to see if it's sentient. All it's doing is responding to prompts based upon its training. And one of the things that Mark Madsen points out is GPT, the P stands for pre-trained, right? So it was already trained, and then you kind of let it loose in your environment. That's why you need all these guardrails around it, whether underneath or above, right, Terrence?
Yeah, exactly. Yeah. So we just have to focus on what it's good at, and it's hard. Like a lot of people feel that these LLMs are sentient or conscious or thinking, right? Especially with
Right.
new thinking models. It's
Right.
important to remember it's math. At the end of the day, they're just calculating the next token, which is really the next word. If you want to simplify it, that's all they're doing. There's no cognitive abilities beyond that at the moment.
Right. Well, yeah, that's a really interesting point. And like you mentioned, reasoning models, for example, I think they're just fascinating as a stochastic tool to learn things. And uh, even though it is converted to vectors and then converted back, there's something to be said about what they can see. Like, for example, maybe I'll throw this over to Sammy. I use them a lot to give me an overview or a set of points to consider in a certain topic. And a lot of times you'll see that there are things it brings up that you had not thought of. And in that sense, it's very valuable, right, Sammy?
It is, and that's the part where this creativity becomes even more important. So you don't want to hinder the creativity, but you also want to eliminate hallucinations,
Hmm.
which then brings up this other interesting part. Do we want our models to talk to our data, or do we want these models to talk to the analysis of that data or a curated representation of that data? I think you need to have your enterprise data coupled with its semantics, its purpose, its meaning. It needs to be curated, and it needs to be made available to these agentic systems or LLMs with enough surrounding information that that conversation starts up. Up, sorry about that. I think my
There,
yeah,
that was one of your phones. That was an AI agent, folks. There it was.
yeah, right. In action. So the the idea is you need to actually like make information, make that data available in such a way that your agents and LLMs can make the best out of.
Right.
And you cannot just like, say, hey, zero creativity. You cannot just, turn the temperature to a level that like, has no insightfulness, because then what you said, providing things that you did not think of, permutations that you were not aware of, those are all coming from the LLM's ability to run all those statistical models that might be edge cases or unlikely that seem like hallucinations. That's why it's not just about talking to the data, it's talking about that curated, prepared data that delivers the value, I think, at the other end.
Hmm. Well, and so there are large language models and there are AI agents, and these are different things. Now, an agent can ping a large language model. That's one of the tactics that it uses, right? So the agent is a semi-autonomous. I mean, theoretically, it's autonomous. I think it's really semi-autonomous. And there are layers of automation. It's basically got like the way I like to think of it is there's a sort of outer layer which is sensing for things. Maybe something's going to call on it or tell it something. And then once it gets that input, there's an inner layer that thinks, okay, now how do I solve for this? And it's declarative in nature, right? I'll throw this over to you, Terrence, meaning you give it an objective that you want. I want you to go get this data set, and you allow it to figure out how it's going to go get that data set. That's the declarative side of it. Is that about right, Terrence?
Yeah, that's right. But at the end of the day, it's still an LLM. The difference is it's an LLM that's allowed to, instead of have one response, to have many responses. So it's just calling out to the same underlying mechanism I mentioned earlier, where the string goes in and the string comes out. But instead of doing it once, it's just doing it many times. And you're also arming it with a set of tools. And maybe that tool is get data, draft a response, look at my files, right? And so that together gives a sense of autonomy to this thing that runs for a period of time. But underlying that whole thing is still one in and one out. It's just being allowed to run longer.
That's interesting.
No,
Eh, Go ahead.
Eric, one definition of agent that I actually recently saw, which aligns really well with how Terrence described it, is an AI agent is an LLM loop with memory and tools,
Hmm.
Yep.
right? It's your like, in the really old days when we had declarative languages, like, you had your main function. It's the infinite loop of that main function is your
Hmm.
agent. It doesn't have to be infinite, but it's that loop. It has memory and it has tools that you allow it to use. So that's why sometimes like, it sounds like we're using it interchangeably, but they're super interconnected.
Hmm. That's interesting. And one key, just to make sure we don't drop this ball, is audit trail. And you want for whatever these agents are, there's basically a log file. You want to log, this is what I did, that's what I did, and that log file itself, the totality of that is your audit trail. So you can go back and figure out what happened, even if you don't know why it made a certain decision. At least you know the decision that it took, right, Terrence?
Yeah, that's right. So you want to log its thoughts if it has it, any tools it called, and then ideally each of those tools have been curated for the user, and you've got a log of the tool that was called. What were the arguments like to the tool, right? Like what were the parameters and this kind of thing.
Hmm. And this gets to my biggest question, which is really around access patterns. And you think about the complexity of a network, of an enterprise network. You have all kind of stuff going on. The network sometimes winds up being the bottleneck. I mean, that was the issue with Hadoop when we went through this whole Hadoop craze.
Hmm.
Was if a node goes down, now that node has to be rebuilt, and it's hitting the network to do all that stuff, and it's a real tax. That's I think one reason why you have so much effort being put into software defined networking these days, for example. But when I think about these AI agents, especially at scale, that is a wildly different access pattern that when we have right now. How do you tackle that? I'll throw it over to Terrence and maybe Sam if you want to comment on that. Am I right about this? That it's a very different ball game? And then how do we manage for that? How do we accommodate these different access patterns?
Yeah, it's a great point. I think one sort of frustrating thing for me on the engineering side, and maybe you've noticed this as well, is that there used to be a lot of attention to the number of nines for uptime, right?
Yeah.
And now there isn't. Like you watch Claude and OpenAI, and they are going down all the time. Nobody seems to care, partially. And then the other part is performance. Like Claude, whatever, any AI can take 20 seconds to respond. Just a few years ago, if your data took 20 seconds to come back, like people would lose their minds, right? So we seem to be very forgiving again for AI and LLMs. I don't know where that came from, but in specific to your question, there are fallback mechanisms coming out now. There's libraries. One of them is called Light LLM, and it'll be like, well, I see XAI is down. I'll go to OpenAI. So there are mechanisms coming
Wow.
similar to networking where it'll like route you around to different systems.
That's very, very interesting. Well, folks, we're burning through the hour here. We're up at our second break already. Don't touch that dial. I'll be right back. You're listening to DM Radio. All right, folks, back here on DM Radio, talking to Terrence Sheflin and Sami Akbay of Inside Software. And now I want to get into the meat of this conversation, Simba intelligence. And I had an aha moment or three when I was taking a demo on this the other day, just thinking to myself, how, especially if you have autonomy with these agents, well, how do you set up street lights for them such that they know where to go and where to go through and when not to go? And let's use that metaphor of traffic lights, because you got a whole bunch of these guys out there. How do you essentially orchestrate their movement through the enterprise? And of course, they also have to know what each others are doing, right? That's the agent to agent protocol. But maybe, Terrence, I'll throw it over to you. Simba intelligence, and again, Simba goes all the way down to the drivers, ODBC, JDBC. There are very specific connectors that prepare the data for reports, for example, for dashboards and things of this nature. And when you don't have these, and it's important to understand, when you don't have these drivers, what happens is you wind up exporting data into Excel and you're doing all this sort of offline preening of data that takes a heck of a lot of time, is not very efficient, and is also offline. So it's not really easy to manage and to audit. So that's one really, really compelling storyline around the drivers. But if you could help me understand, Terrence, what is the intelligence side of this and how is it coming into play to route these AI agents?
Yeah, so basically, we took all of the things we talked about so far today. We took connectivity, creativity, prompt engineering, the great amounts of data, hallucinations, creativity, and of course, connecting to data where it is, right? Without having, like you said, to make a copy of it. And we took all these ideas and we basically put them together and built something brand new on top of the proven technology at Simba that we already have that knows how to deterministically connect to and query data. And so the outcome from that is this new product called Simba Intelligence that is able to leverage the LLMs in a way where it makes sense, where it can be used well, but controlled, and not give them broad access to some sort of database and just let them go nuts with SQL, but rather give them a way to accurately form a query and then let our engine built on known technology take care of connecting to any database or any database type anywhere.
That's really interesting. I mean, you're really supercharging the ad hoc query is one way to look at it. Is that about right?
That's exactly right.
Yeah. And that this is really important because, traditional reports, if you think about the history of business intelligence, you started with reports, You got them one a month or one a week or something along these lines, and you kind of absorb it in your mind, and then you would go and make decisions based upon what you read. And what we're really doing is we're getting closer and closer to now, and closer to the granular need of a particular analyst who doesn't just want some generic report. He or she wants a very specific piece of information about a very specific part of the business. And being able to manage the authorization, the security, the governance, all those things. If you try to do that stuff manually, basically it's just a non-starter, and people won't even try. And that's like the opportunity cost as I think of it. And maybe Sammy, I'll throw this over to you. It's a very, very important thing to keep in mind, because when something is difficult to do for the end user, they're probably not going to do it unless it's really important and they have to do it. So the more you can grease those tracks, the more engagement you're going to get, the more use you're going to get of the data. And that was the whole point of having BI in the first place, right, Sammy?
Absolutely right. And there are also a few interesting stats, not the 95, 97%, like, the meme stat, but there is a tremendous amount of load that we're putting on data engineers.
Hmm.
Um, Worldwide, there are almost 3 million open positions for data professionals and about quarter million positions in the US for data engineers, because data engineering is becoming increasingly sophisticated. You have to be both a systems person as well as a database person as well as a developer at some level. And the amount of data that you're handling has been going up, and it's been going up, exponentially. So because of that, it's something that you can no longer get away without automating. You have
Hmm.
to automate the tasks associated with making enterprise data readily available for everything that we're trying to do downstream.
Hmm.
That's pretty critical. And Terrence has done, or Terrence's team, they have done a tremendous amount of work in this. As you're well aware, you cannot build data infrastructure technology overnight. You cannot just vibe code, infra technology, because it has to be deterministic. Bugs are super detrimental. What we're doing here is bringing together true and tested technology, a long pedigree in solving enterprise mission critical problems, with newest, most kind of advanced language models, most advanced AI approaches. But it has to be a combination of prudent, tried and true tooling coupled with this new way of thinking.
Hmm. Yeah, that makes a lot of sense. And you do have to think carefully through what you're automating and how you're automating it. But what I like about this is that you're leveraging 30 years of connectivity experience. I mean, you guys, of course, have data about how these systems connect to each other, how long it should take, for example. I mean, it's basic stuff like how long should it take to connect to this API? How long should it take to get the information back? To be able to manage all that and measure that is pretty valuable stuff, because that's what goes into the engine that decides how to do things, right, Terrence?
Yeah, that's right. It's all about being able to quickly get the data to some endpoint, right? And before that endpoint was probably a chart, right? Some sort of visual. And now it's not. Now it's the AI doing it. So yes, that's absolutely a huge part of it.
Yeah. Now, this is important stuff. And, let's talk about semantics. We've got a few minutes left in this segment here. We keep hearing about semantic layers, the importance of semantic layers, and that's the business definitions of things, right? And that changes from one business to another, which is why every company kind of needs their own semantic layer, which understands their enterprise data. Can you talk about why that's important, Terrence, and how you actually do that, how you get that done?
Yeah, so that's a great question. So like one of our data sets that we have for our executive has well over 200 tables, and each table has well over 200 columns. And one of them has 40 columns named opportunity and bookings. And so when they say, I want the bookings, well, which tables and which columns, right? So this is where the semantic layer comes into play. So semantic layer really is just adding context, grouping fields or explaining what fields are in some way. And
Hmm.
so with Simba Intelligence, we have our own semantic layer where you can define how these tables are joined. You can provide additional information as well as have the AI generate it for you. So it kind of goes both ways. The AI can analyze it and help, the data engineer craft this semantic layer, or they can just craft it themselves. And either way, this semantic layer is what eventually goes to the LM to help it decide. So when a user says, how are my sales? And there's 20 columns, named bookings or opportunity or ARR, it will know which one to use based on context, rules, semantic layer, governance, security, and all the different things that go into that specific layer.
That's interesting. And is this also where you're starting to see the LLMs come back and ask questions? Because I noticed something when I tried to use it for layout. And by the way, ChatGPT at this point in time sucks at layout. Okay. It does not do a good job. It's horrible. I used to come from the layout business. No bueno. But it was interesting. It kept asking me questions to clarify, and I'm thinking to myself, huh, this is interesting. It hasn't done that before. And I think it's in part because of the cost of actually doing this final step of the process. And I think that from a strategic perspective, the folks at OpenAI are like, all right, let's make sure that it asks enough questions to where we're not doing the expensive part of this thing multiple times, because that's when we start losing money. Because that's the other side of this equation is like, all right, how much is it really costing to do this stuff on the other side? And there's this massive land grab right now. But is that, you see where I'm coming from? Is that where it's like trying to ask you questions just to make sure it gets it right before it does the number crunching that takes the real compute?
I have noticed GPT is very like it always follows up with a question. I suspect they are doing that for the exact reason you said to get it right. I will
Hmm.
say at like a broader context that questions in themselves are kind of a currency, especially when it comes to data. When we give a new user access to data and they get an empty text box, they don't know what to type, right? Is it sales data? Like, what is it? And so another part of our system is generating suggested questions based on the
Oh,
data. So like what are the distinct values in each column? What are the min and the max years, right? Learn it all together with the semantic layer and come up with these questions, these suggested questions. And I really feel they're a currency of type in themselves.
that is a very, very interesting point. I like that. And I think it's also an excellent strategy from a software development perspective to do that. And it kind of gets to one of my themes, which is a lot of the value that we get from AI will come via suggestion. And then you kind of take action on that or not. But it's up to the user to do that. So it's this tool, this little helper that's saying, hey, have you tried this? Have you tried that? And that is extremely valuable. Well, folks, our final segment is coming up in 1 second. We'll be right back. You're listening to DM Radio. All right, folks, time for the podcast bonus segment here on DM Radio, talking to Terrence Sheflin and Sami Akbay of Insight Software about LLMs and mitigating hallucinations and really getting the value from these things because they're so powerful. We can't not use them. I mean, that's the thing. It's like this is the candy of candies for enterprise executives. It's like so much fun and engaging to use them. So if you get the governance side right, you're really going to get somewhere. And Sami, in the break there, you made a point about how sometimes when it's asking you questions, it's trying to figure out where to route that, whether that's to a sort of math engine, for example, or to a different model, the whole multimodal thing, to get you the right answer for the right problem, which, human beings are, we have incredible minds and we have all of this lifetime of context in our heads. And that's why it's kind of hard to remember that AI agents don't have that. And you have to be very explicit with them to give them what they need. But what are your thoughts about that, about this multimodal side of things?
Right. Not multimodal, but multimodal.
Oh,
Because
multimodal,
it's
right.
like that just one letter,
Yeah.
M-O-D-L versus M-O-D-A-L.
Right.
Uh, so usually when you ask something, and if it comes back and asks you a question, it's because it's trying to clarify your intent.
Hmm.
Clarifying your intent is important because it's going to try to route that request to the best model for that particular question, right? You can use the most advanced, most expensive models, and that's not economically viable. But it's not only about that, it's also being able to support different models for different tasks and purposes is going to become increasingly important because, especially in the world of enterprise data, we need to think about data residency. We need to think about which models or which tools are allowed or compliant with certain requirements, you may end up in situations where, hey, this particular model can only be used for healthcare information processing. That data may have to only be available in a specific data center, and it may only use underneath MCP servers or tools that have the certain qualification or certifications. And this is why I think the whole model flexibility is going to be something very key as we keep deploying these new applications and new technology.
Yeah, that's very interesting. And Terrence, I'll throw it over to you. So Simba intelligence, maybe you could explain Simba intelligence versus MCP, for example. Where does MCP, model context protocol, leave off, and Simba intelligence pick up?
Yeah, so MCP is kind of a way that you wrap tools so that an LLM can call them. And Simba Intelligence can get data. So they're kind of two separate things, but Simba Intelligence has its own MCP tools that it surfaces for Claude or OpenAI. So these LLMs can actually call using the MCP tools into our application and then eventually get a database query executed, but in the context of a user because these MCP tools have authorization on them. They don't just execute. When you tie the tool to the AI system, it asks you to log into our system so it knows who you are, and you can't see data you're not allowed to see.
Yeah, and the sim intelligence, it's kind of like when you think of these agents, one of the things that I've heard is that you should try to get them focused on a particular thing. Now, some people say, no, I want to go the super agent approach, which is interesting. There's a bit of a debate going on in the industry right now. Do you want your agents to be very focused and do a handful of tasks like pull data, analyze data, develop questions or whatever it is, or super agents? And when you look at Simba Intelligence, it's like a data engineering agent, right? That's what it is. It's designed to optimize data engineering for the purpose of delivering valid responses. Is that right?
Yeah, that's right. Our job is to get data to the end users or the AI or whatever system is asking for it. And we're kind of like Switzerland, like we're in the middle. We don't care what LLM you want to use. We support all of them. And we don't care what tool you use to get the data out of our system. You could be using Claude or XAI or GPT, or maybe none of them. Maybe you're just making a traditional web application and you're programming it and you just want to call out to some REST API, which we have as well. So yeah, we're trying to act as the arbiter, a safe way to do translation from natural language or whatever an AI system wants to give us or a user wants to give us to a query that can execute with all of the things that you need to get that data and get the right data and not too much data.
That's interesting. And here's a bit of a curveball question for you, Terrence. When Simba Intelligence, I know it's fairly new, but when it's deployed at a customer site,
Hmm.
will it learn over time about that customer's environment? Is there this capacity for it to capture intelligence and retain intelligence about the landscape, the topography, what kind of questions it's being asked, and thus incrementally optimize what it does?
Yeah, exactly. That's exactly what it does. The more the users use the system, the more semantic layers they build in our system, the more they upvote and downvote responses from it. It takes
Right.
all of that into consideration. So the next time you ask it to build a semantic layer, it'll look at all the previous ones and say, well, these ones were good and these were bad, and it'll use that. And the next time you ask it a question about data, it'll use the previous answers and it also will use like answers that were well liked as suggested questions to other users. Like, well,
Oh,
everybody's
right.
asking this one, right? So yeah,
It's like the IT crowd. Have you tried turning it off and on again?
that's right.
Right. That's a good one. Sammy, I have to say, that is very, very interesting. So, I sit there and I think about this stuff all the time because I'm a data geek. And I think about historically how much time and effort we kind of wasted de facto, like moving data that didn't need to be moved, analyzing the data that didn't need to be analyzed, like all these things that are done because that's the way we did them. And that's kind of how we got here. This Simba intelligence layer can really optimize for that, right? Can really optimize for making sure we have access to the systems that everyone keeps asking questions of and not worrying so much about all the systems no one asks questions about, which means over time, you're really refining and preening your information architecture. Is that right?
It's absolutely right. And when you say we moved data that we didn't need to move, well, we actually needed to move it back then because
Right.
compute power was not there. The different database technologies were not sufficient. Today, you can do virtual federation where the data resides and sits where it needs to sit, and you can bring multiple engines onto that data to do these in-memory joins and these
Wow.
operations. And this has only become possible with elastic computing, the ability to scale up and down. So we're these are things that are actually only possible now. It wasn't conceptually it was there, practically it was not. So first of all, that's actually a big shift. The second shift is different architectures need to be supported for different use cases. So, for example, let's say you're a European bank, you may or may not be able to move data from one domicile to another. And if the data needs to reside in a specific place and you need to just do virtual, federation of it, this approach is your
Wow.
best path to being able to use that data in all these applications that make cross borders.
Right.
Similarly, there are other situations where you want to create your analytics, data warehouses or data lakes or the architectures for, carrying out analytical tasks. These are not necessarily mutually exclusive. The modern data estates need to combine both federation, virtual federation, as well as, the data
Wow.
pipelines. It's a complex data world out there, which makes
Yeah.
our lives more exciting, by the way.
Yeah. And let's close with this, Terrence. I'll throw it over to you. I mean, I think this is so exciting for all kinds of different reasons. Number one, let's say you're a Snowflake customer or Databricks. Those are not inexpensive solutions. It's very expensive to have these things lumbering out there and sitting. And that's why even Ali Ghodsi keeps talking about pay as you go, keeps talking about consumption, right? There's all this focus on consumption models because people recognize that it's just incredibly expensive to do this stuff. So what I see here is this amazing possibility is this layer of Simba intelligence can not only optimize your data infrastructure and get your business users rocking and rolling, it can also optimize the cost above and below them. So of that whole environment, because you'll start to understand, hey, I don't need to keep all this over here just in case someone needs it. Now I can basically move some to cold storage or whatever. I can make more decisions about how to optimize the cost side. And that is a very important side of the equation. What do you think, Terrence?
Yeah, absolutely. That's correct. Like people have been moving it into the cloud like Snowflake, and now Snowflake wants you to keep it there, right? They have
Right.
Cortex and whatever, and they're like, keep your data here and use our tokens, and we'll just upcharge you, and that's great. We're trying to do the opposite. Your data probably wasn't in Snowflake originally. It was probably in Postgres, maybe S3. It doesn't matter. Wherever it is, leave it there. We'll come to you. We'll meet you where you are. You'll spin up an LLM where you are, and nothing leaves anymore. It's all in your own cloud to your own cost. There's no upcharging. You pay wholesale. So yeah, that's absolutely, and I think that's the right way to do it. You don't have residency concerns, and yeah.
That was just fantastic. Well, folks, look these gentlemen up online. Terrence, two R's, Sheflin, Sheflin, and Sami Akbay, Akbay, Sami, Sami. Insight Software, Simba Intelligence, new stuff. To Sami's point, we can do these things now. When you have this layer, you can optimize above, below, and inside. Really, really good stuff. And the residency stuff, I promise you, data sovereignty, big, big issue, not going to be going away. Look them up online, folks. You've been listening to DM Radio.